Okay, it's Sunday night. Let's get this done. I can see my audio is on. I think I may have had this thing recording for a while. I may have to snip it, edit it, or something. But let's jump in here to this week 7 Understanding Road Survey Stakes is the main theme here. And there's some interesting reading in here. One of the things I'd like for you to know is what this fellow says, that everyone, the inspector, superintendent, foreman, and grading equipment operator, needs a good understanding of how surveyors stake the job. Not understanding the stakes is like having the specifications and not being able to read. Sometimes I run into a little barriers on students, that say, well, uh, I plan on going to work for someone that has GPS, automated machine control, all those things. That is excellent. One thing that you need to know, that everything, and I mean everything, in automated machine control is based on these principles that we're teaching. If you get this stuff, they're just going to have to show you how to turn the video on, or the digital terrain model, or whatever you're using, and you will know when things are not right, because this kind of understanding gives you a visual in your mind of what the project should look like, or at least the area you're working in. So let's move on. This is a little bit complicated. This is based on, or a step up, or the application of, for you guys that were in uh, introduction to grades. Uh, we had a reference point to slope state. This was leading up to what we're going to be talking about to this week, road survey states. Uh, let's see what's in here. If the overview. Oh, I'm on your. Never mind. Here we go. Understanding road racing. Overview. Coming. Interpret a surveyor's information stake. These reference stakes are called reference stakes. They're called reference points. A slope stake, they're called information stakes. But they're telling you where to start and what to do after your grade setter's reference stake is set. It also, the first thing on that stake, it'll tell you where to set your reference stake. We'll be talking about single line information stakes, where you go back to the same point for your horizontal and vertical measurements. And we'll be talking about, double line information stakes and reference stakes and slope stakes. That will be, each new cut and our horizontal distance will be based on the preceding cut and horizontal distance. In other words, you will go from one place and then you will measure to the next place, like going from the reference stake down to the ditch, and then you'll have another reading that says, and then I want you to feel so much to get back up to the edge of pavement, and so on. Some of that stuff will come clear quickly to some, and some is a little slow. I've been going through it this early this evening, and just making sure that I don't get hung up. It's easy to get a little bit messed up, a little confused for even seasoned surveying folks, grade setters. So demonstrate knowledge of calculating slope stakes. It's just absolutely essential that you understand how to calculate percent rise and fall, how to calculate slope ratios. And I will illustrate that as we move through some of these examples. So I don't know if I can go right straight back to the module. Look, it did. So where do we start? Right here, here, here. We just did the overview. Let's see what this says right here. Survey stakes. In the textbook, Excavation and Grading, I want you to read chapter 1, pages 5 through 18. Don't answer the questions at the end of the chapter yet. They will be on your week 7 quiz. You don't need to submit your answers now. You will submit it when you finish that week 7 quiz at the end of the module under assignments. Let's see if it'll take us to something next. Oh, it is a PowerPoint. And these are very good illustrations. I have a friend that does graphic design, and I kind of show him what we're doing, and he makes it really good. I guess he's an illustrator, probably more than if there is a difference. But here's a file, a PowerPoint that we put together with my information and his expertise. So we're going to talk about survey stakes, and I guess we're going to talk about single line information stake to reference stake. Those of you that went through Introduction to Grades or GR 101, we did this. This was part of our this was a module, how to determine these points of reference, such as the top of the slope, the bench, and then it moves to a hinge point, and then it moves to the edge of pavement and into the center line. Keep in mind that a highway being staked will have information stakes set on opposing sides of the roadway moving toward the right of way. They will one side will tell you how to get to the center line from, say, the right side of the soon-to-be road. The other side stake will tell you how to get from the left side soon-to-be road to the center line. And those little segments of road are called, they're turned into cross sections, and we may be able to have time to touch on that. But they're templates, and one template may fit at station station 3 plus 0 at 300 feet. And that may be good all the way to station 5 plus 0. And then there'll be a transition to, you will change, because what's happening, you have to change your back slope, your in slope, or something has to change. But as long as the template of the road cross section that you're using works, you'll continue to use the same one. So I love this little PowerPoint, I think. Excavations begins with the survey, the site or the area. The survey crew sets stakes and hubs of reference points. They're little 2x2 squares of wood with a point that you drive in the ground, and as opposed to using a crow's foot, which you may remember from your grades 101 or grades introduction or grade. Establishing points from which excavations and distances are measured. Excavations being cuts and fills. Distance would be in how far away from the reference stake this is to be. Beside each hub is an information stake explaining the grades. It's just a set of directions on a piece of wood at various distances from the hub or other reference stakes or points. These stakes are usually cut, fill, or slope stakes. If you go to figure 1.1 on page 7, we will begin the fun. This is, I think it is. This is the figure with a little bit in I'm not saying animation, it's not moving, but it's maybe to help you out. First, look at figure 1-1. You're looking at a profile view of the road when you look at that figure. I can't show it to you on on this PowerPoint, but I can show you this stake right here where my little arrow is this stake, and all of this information is on this stake. This is going to be where the grade setter begins, right here. This stake is going to tell him where to put this stake, and he's going to tell him right here, put your reference stake 1 foot below my hub and 5 feet away from me. So let's go down here. He's going to drop down a foot and go out 5 feet, and he's going to put his reference stake right there. I think we'll have a little bit better illustration coming up. But keep in mind, this is proposed grade all the way down to the ditch, up to the shoulder, let's call it, but that's a hinge point also. And this is the edge of the pavement, and the road goes all the way out to the center. And then over here will be another stake just like this, and it may be up high, or it may be way down here low, and it will be a fill situation getting up to the center line. And we will see, I think, an illustration of that. On these information stakes, and states and even companies vary a little bit, but on the back of the stake is the station where this stake is located. This one is 350 feet from the beginning of the road or the project. It's station 3 plus 50, and it is that a 5? 5, it's 54 feet from this guy right here to the center line, and you will see you can add things up as we go. But this being a single line stake, everything is measured. Like once you set this stake, it says and then, and after it says and then, you go into single line, which every horizontal and vertical measurement is referenced back to this reference stake, and there will be a hub here. This tells you to set this stake 1 foot lower and 5 foot away. So to set this stake, you will go down a foot and you go out here, and that's your reference stake. That's the stake you set for your reference. It also, you would put a 2-foot boot on it for convenience in case you're sitting down here or you're up here, and instead of laying on the ground, when you start slope staking, you'll have this 2-foot boot, and you know this 2 feet is always above this grade right here, which I think is given right here. This is on the side of this stake, and it is the elevation of the reference stake, of the surveyor's information stake. It's on the side of it. In other words, you're at elevation. When you're at the hub of this stake, right here, you're at elevation 83.4 above sea level. This right here is a typical, and it's also on the side of the stake, perhaps over here, but it's telling you, I'm sorry, I lost it. It's on the side. I'm not sure what SE stands for literally, but what it is telling you that you have a minus 2% fall from the center line to the hinge point, or from the center line to here. That's the cross slope. And I don't know what that literally means, but you have a 2% cross slope. So on this highway, we'll be drained, so the water will run off 2% here, and there will be 2% here. And these dimensions are going to make you, or if you follow these accurately, you will end up with this 2%. It may not say 2% anywhere on here, but when we calculate it, we're going to see that as 2%. And that's that. 2 to 1. That's this guy right there. And we will prove that momentarily. So we're going to take it point by point. And when I say that, I always say it's good to think about points. You know, yes, this is going to be a point, but it's going to be from this point to that point, and from this point to that point. So you're plotting points, like on graph paper. If you go back to our, when we get to page 7, you'll see one on the same, I think, plan on page 1, on figure 1.1, page 7, is what this is talking about. I do believe, as a matter of fact, I'm really sure it is. So if you have trouble reading these numbers, you can go back to page 7 in your handbook and you can see the numbers bigger. But these are very, very clear, and some of these slides are not. So let's get started. I hope you're up with me. You have a profile view of a proposed slope to a ditch, an end slope to the shoulder or hinge point, if you will, and then this is going to be 4 or 5 foot at a slight fall or slight rise from here to here. But you will find out as we go through this that from here all the way to here is a 2% fall, like we asked for, or like we want to keep the water up. So we start with the reference stake here. We're going to start with a reference stake. Put the reference stake 1 foot below my hub and 5 foot away. Let's go down. 1 foot below where my hub is, right here, and 5 foot away. Now, could we calculate that? Of course we can. What's the vertical? 1 foot. What's the horizontal? 5 foot. 1 divided by 5 equals 2%, 0.02. Fall in here. I think that might be 20%. I looked at my decimal wrong. So we want our reference stake here. Everything else we do will be from this point, either down or fill up. It will be always coming back here to this. There will be one double line, and it says reference stake 1 foot down, 5 feet away, and then. And that means everything, when that's done, everything will be measured from this reference point, not here. The only thing measured from the information stake is where to put the reference point. And then the ditch, we will cut 10 feet at 20 feet. This diagonal line separates the vertical, whether it be fill or cut, from the horizontal. And you literally read that as at, cut 10 feet at 20 feet. So that would be cut 10 feet at 20 feet, if that's the real, here it is, to get to the ditch. Cut 10 feet at 20 feet. That's how you read that. So that's how it looks. This now we're not going to draw these lines. This is all under the ground. All of this right here is the original ground, and it's got to be removed and carved out and put over here in this fill area because we've we've got to fill all of this in, and we'll use as much of this as we can to do that. So to get to that ditch, the ditch is cut 10 feet at 20 feet, cut 10 feet at 20 feet. Now, somebody tell me something. What is that slope? The ratio of the slope is determined by taking the horizontal distance and dividing it by the vertical distance. So glancing at that, that's a 2-to-1 slope. 20 divided by 10 is 2. So that's a 2-to-1 slope. He could have said cut 10 feet at 2-to-1, same thing. But this is telling him, the survey, he don't care. He wants it right here. If that's a 2-to-1 slope, fine. Okay. Now, so we know we got our point where the bottom of the ditch is going to be. It's going to be 10 feet down lower than this reference stake, and it's going to be 20 feet away from it. Again, we're looking at a profile. This thing continues in 3D in this direction. I've gone over that several times, and I hope you have adapted to that. So that took us to the ditch. Now, what's next on here? Let's look and see. Hinge point. So we're at the ditch, and we need to get to the hinge point, but we're not going to measure from the bottom of that ditch in a single line stake. We're going to go back to the hub here and measure 10 foot down. And measure 8 foot down at 24 feet. So let's see what that looks like. So we're going, are we to the ditch? 10 foot down, 20 foot down. I don't know. We've got to go to the hinge point next. We're doing the ditch. Slow down, Scotty. So we're going to cut 10 foot from this stake because this says and then. From this stake, we're going down 10 feet over 20 feet, and that's going to be the flow line of the ditch. The flow line of the ditch is the bottom of the ditch. The flow line of the pipe is the bottom of the inside of the pipe. So that's where the bottom of the ditch is. Now, what's next? The hinge point. It's going to have to go up. Are we going to fill? Are we going to have to fill? Let's look up here and see. Next thing is hinge point. So, it's not a fill. Well, for crying out loud, it's got to go back up. But remember, I said we're plotting. This says cut 10 feet at 20 feet. So let's look at that once more. Cut. I can't. I already passed it. Cut 10 feet at 20 feet. Now, to get to the hinge put, we're going to cut 8 feet. So we're going to be 2 foot higher than the bottom of that ditch. We can tell already. And we're going to be 4 foot further away from that ditch, aren't we? So let's see what that looks like. Cut 8 feet at 24. So I'm going down on cut 8 at 24. And see where that's going to put me? That's going to put me up here. Actually, that's going to put me 2 foot higher. Even though it's a smaller number, it's going to put me 2 foot higher. Cut 10, cut 2, at 20, at 24. So it's 2 foot higher, and it's 4 foot further away. So what is that slope? Horizontal divided by vertical. Vertical is the difference in the height here and here. That's 2 foot. What is the horizontal? It's the difference in 24 and 20. We're 24 feet further. So 4 foot divided by 2 foot. That's a little 2-to-1 slope going up to the hinge point. Okay, so we've made it out here. We're 24 foot away from the reference stake, and we're 8 feet lower, so that we will be 2 foot higher than the ditch. Now, let's get back and see who's next on here. This is the edge of pavement. We're going to go from the hinge point. We've already at the bottom of the ditch. We're at the hinge point. It's 8 foot down. But we want to go to the edge of the pavement, where the pavement starts. This is dirt, grass, gravel, whatever. So let's see what we got to do to get to the hinge point. It's, have I done that? No, edge of pavement. Sorry, guys. Edge of pavement, cut 7.9 feet. Let's go see what that looks like. Edge of pavement. 7.9 feet at 29. So here we're going to cut 7.9, and this is 8 feet. What's the difference in this height right here? Let me see. A tenth? Cut, instead of cutting 8 feet, I'm going to cut 7.9, so that's going to put me a little bit higher. How much higher? A tenth higher. So I'm here, and I'm going to go how much further? 29, 20. I'm going to go 5 foot further. That's 5 foot right there, and I'm a tenth higher. So what is this little slope? This is a slope going from the hinge point up to the edge of pavement. The horizontal is 5 foot, and the vertical is a tenth. So I'm going to take 0.1 and divide it by 5, and guess what that equals? 0.02. That is 2%. That's a 2% rise from here. So we're in that 2% thing now. So we've made it to the hinge point, and from here to here is 2%. Next thing I think is going all the way to the center line. Let's take a look at that. This brought us to the hinge point. I'm sorry. This brought us to the edge of pavement by going 7.9. That took away that tenth, gave us that tenth from this eighth to make us a little higher here, and we're going out 29. Edge of pavement's 29. This is 49. So let's look. We're going to cut 7.9 down, so that's going to make us a little higher for that edge of pavement, and we're going over 29 feet. So if I cut 7.9, that was 8. I'm going to be a tenth high. I already did that, and that's the 5 foot run, and that's where we get 2%. We've got to go to the center line. We haven't done that yet. And here is its information. So these are not, all of these information, this vertical, everything goes back to this reference stake. From here back to the reference stake for your elevations and the deal. So here it says cut 7 5/10. Look at the difference. There's 4/10 in the difference here and the difference here. So that's going to mean something. This is going to be 4/10 higher than the edge of pavement. So there's a vertical of 4/10 there. We'll do it. How much? What's the length from the edge of pavement to the center line? 29, 29, 29, 49, 20 feet. 20 feet from the edge of the pavement to the center line. Edge of pavement to the center line. Do you see how I got that? Because the edge of pavement is 29 feet out, but the center line is 49 feet out. So that is Am I saying that right? Is that 20 feet? I'm going to do the calculator. 49 minus 229 equals 20 feet. So look what we have here. Once again, let's see. Are we continuing this 2% like we're supposed to? Well, let's look at the difference between this height and this height. That'll get our vertical. Here's cut 7.9. Here's cut 7.5. So center line is 4/10, 5 from 9, higher than the edge of pavement. So our vertical is 4/10. Our horizontal is 20. Let's take that 4/10, 0.4 divided by 20 equals 0.02 times 100 is 2%. So look at us go. We've taken a stake and we've built, plotted for now, these things. So on the existing ground, there'll be a stake saying cut that far. There'll probably be a stake saying cut that far. Now, when we build this thing, rough grade it, we will get a pretty good slope in, but when we get somewhere around here, we will cut this thing straight across, and then we'll do fine trimming with a motor grader and carve this out. Remember, going away from us and toward us is the way this road goes. Good job, guys and gals, if they're there. Now, enough of that. You should get this. Nothing, no, of that. We got a whole lot more to go here, so I'm gonna keep the thing moving. What are we doing here? Double line stakes. Look at this. Looks like a shelf. These are do this and then do this and then do this. All of those double line means then. Strictly what's happening here is everything is measured from the preceding point. Check this out. Cut 1 foot at 5 feet. That's for your reference. Oh, this gets me confused sometimes. Here, these are double line. We'll get that in a minute. So I've got to do both here. Doing this in your head is hard, but this is gonna take us to the same place as this. Both these stakes are gonna take us out. Remember, we're 54 feet out. That right there, 49 plus that little 5 makes 54. What is this? 25. These are horizontals here. 25, 5 is 34. Whoa, Scotty. Is that what that says? I'm going fast. This is 20. Am I right? Wait, let me get on the right picture. Do you have the single line in your book? Yes, you do. And the double line. So we got 20, and we got 25, and we got 29, and we got 49, and we got 54. So this stake got us to this. That's not 54, but you put the 5 in there, and it is. See, it's going to take us to the same place, and it's going to be a little bit difficult for us to do this. If I had a little whiteboard, we could be calculating, or you can calculate. So let's start with the single line stake. Everything about this stake is double line. There's only one double line here, but that's true here, and the rest were single line. So let's see what we can do with this thing. And I think we're going to the same places. I'm just not real sure. Maybe not exactly. This stake takes you to the same place this stake. Look at the first deal. This is your reference stake. It's going to tell you where to set. This is your information stake. and it's going to tell you where to set your reference stake. So is this. So this is reference stake to slope stake. When I say reference stake, I'll distinguish that. I'm saying the surveyor stake, reference stake. This is the information stake. So to set your reference stake, this wants you to cut 1 foot down. I don't remember what this one wanted. It wanted you to go 1 foot down and 5 foot over. So does this one. 1 foot down, and we don't have anything to look at here. We just got to talk ourselves through this. We got to go 1 foot and 5 foot away. Look at this. 1 foot down, 5 foot away. These two are saying the same thing. To get to the ditch, we're going to cut 10 feet at 20. That's what we did a while ago. And we're going to do it here also. And then cut 10, at 20. Is that 20? Magnifying glass. I believe it is. And so is this. But here's where things get a little different. From here on, everything we measure goes all the way back to this reference stake. These are going from the last known point. So the first point for each is a cut of 1/10. And these are not two different slopes. These are the same thing. It's just saying we can do it this way or we can do it this way. Why would this way be more accurate? Because this one is, every reference is from the previous point. So you can, if you make an error here and an error here, it doubles. It's going to make errors all the way down. But if you brought all the way back to the same point for these verticals and these horizontals, you're going to have a more accurate point here. But that's okay. If we can get away with this, this is way easier because we don't have to calculate all of these things each time to go 20 foot away, 24 foot away, etc., etc. They change. But so we know the reference stake. Let's look, and then I want the ditch at 10 feet, 20 foot away. Same thing here, same thing going on. Now here's where it changes. Next thing is the hinge point. So it says cut 8. Let me give it a magnifying glass. Yes, cut 8. Let me look on the book. Cut 8. The book's easier to read. Cut 8 at 24 foot. What does this one say? Fill? For crying out loud. What do you mean fill? It says fill. I'm lost. Am I looking at mistake? Where's mistake? Oh, I'm looking at the wrong mistake. I'm looking at the wrong page. We drew this, I guess. So the stake here says cut 10. This stake here cut 10 at 20 at 20. But here the stake says cut 8-2. Going to the hinge point, and it's got to be at the same place. So this is going down 8 foot, and it's going over 24 feet. This one's filling 2. So why is it filling 2? Well, it's going from this reference. This is a diagonal line. This is not a bookshelf. It looks like a bookshelf in 3D. But this is the diagonal line with the cut and the cut. So this one's cut 10. This one is cut 8. So if I'm going from a cut 10 and I want to be at a cut 8, I got to fill 2 10s. See? And that puts me at the same elevation of 8 foot by going from a 10 and take it away 2 feet. So this is at 8 feet. This is at 8 feet. Now let's look at the difference. This one says 24 feet. This one says 4 feet. think back to that ditch, or let's go back to that ditch. And oh, here's a cool looking double line. I don't know if I want to jump to this right now, but I will in a minute. To put me at 8 foot here, I was 10 here, so I have to fill 2 feet to get to this point. This is 10 foot down. This is 8 foot down. I don't have my single line. This is 8 foot down. So I got to get to 8 foot. Well, I'm 10 foot down here. If I fill my next one 2/10, I will be at 8 foot here. So I'll be at the same elevation. I'll be at the same point. If I'm 24 foot here, if I'm 20 foot here on my horizontal, and I measure from here 4 feet, where will that put? I measure, remember this is from this point to this point, from this point to this point. So to get my distance from the reference state, if I'm 20 feet here, I want to be 24 feet here away, just like this is. So what I have to do, I have to move another 4 feet from this 20 feet. From this 20 feet, I have to move another 4 feet. And that puts me horizontally the same as 24. Hang in there, everybody. I'm also 8 feet down to coordinate to equal where this stake says I am. Edge of pavement. Edge of pavement is going to be a little wee bit higher, I think. In this case, I think it was for a tenth higher. So let's see what happens up here with the single line. Remember the single line, I got to go all the way back. So my cut is 7.9, I believe that is. I'm going to verify that by looking at the book. I'm afraid it is 7.9. What is the difference here between 8 and I'm cutting 7.9? I'm a little bit higher. I'm actually a tenth higher at the hinge point. And this is at 29 feet. So I was at 24 here, remember? I had 20 and I added that 4. That put me at 24. So here I'm at 25. I'm at 29. So if I take that, if I add 5 feet to that 4, where am I? I'm at 29. Same thing. So we got to the edge of pavement. This character. Now we got to get all the way out here. And remember that was 20 feet just from memory. And it was, I think, about 4/10 higher. But let's see. Let's see if that's what it calculates to. Look at here. To get to the center line, I want to cut 7. Holy moly. I think that's 7.5. I'm using a magnifying glass out here, guys. 7.5. So what's that going to do? I want to do 7.5 here because I want to be 4/10 higher than this. This is cut 4.9. This is cut 7.5. And remember, it related to that previous one was 4/10. So this is going to give me my 4/10 higher, because 9 minus 5 is 4/10. So how am I going to get to 49? Well, here I was at 29 when I stuck that in there. So I'm gonna add 20 feet to this last 29. I did that by getting 4 feet there and then adding 5. That made me up to 29. And this one, if I'm 29 at this level and I want to be 49, so the double line makes me add 20 feet. And if this is 29 like that, and it is, then if I add another 20 feet, I'll be at 49. Look at this one more time, just to let you know. 49. These, you can't do that with these, but these, watch. 20, 25, 29, 49, 54. So this stake brought us to the same point as this stake. This is the double line stake that we just did. Remember that 5 and that 5. I wish they was on the same, but they're not. But you can see how this cut 10, and if I only cut 2 here, that made that 8. If it's 20 foot away and I add 24, I'm at 24, right? If I cut a 10th, if I cut a 10th of a foot, I'm trying to think, I'm at 1.9, and all of that adds up to 5 feet. I think I'm going fast and I may be skipping things. But to get there's my 4/10 that I want coming from the edge of pavement. Remember, coming from the edge of pavement, we needed a 4/10 over 20 feet to get that 2% fall. And this goes on and on. This is cool stuff here. My buddy did this for me. So let's, well, this is the one we just did, right? Yeah. Yeah, there's that 10th. We can go through it right quick. It changes. The first thing is cut 1 foot at 5, 1 foot at 5, ditch 10 feet at 20, ditch 10 feet at 20. But HP needed to be going all the way back. I cut 2, and that made it, because I cut 10 here, I cut 2 here, and this made this 8 feet. And I had 24 foot here, and I added a 4 foot to that 20, and that made me 24. This one I cut a 10th, and I'm trying. I kind of, what did that do? Edge of pavement. There's what it gave me. 0.1. I needed a 0.1, so I cut a 10th, and let me see. Let me not get lost. I'm not lost. I want to go back here, and there's that. If I cut 2 foot here, I cut a 10th here, and that leaves me, gosh, I hope this comes out right. Cut 0.1. So what am I at? 2 minus 0.1 equals, oh, I can't do that on my dang computer. 2 minus 0.1 equals, I got to turn it on. I cut 2. So here I'm going to cut 0.1. Yes, yes, yes. 4 foot, that puts me at the 24. 5 foot, that puts me at the, 24. Adding 5, 29. That's where I want to be. Yep. Adding 4, 29. That's the 20. It's not on here. Add 5 feet. I'm at 29. And then if I cut 4/10, that leaves me that 1/10 higher that I need to get to the center line in over 20 feet. That if you take 0.4 divided by 20, you're going to get 4/10. No, you're not. You're going to get 2%. I'm sorry. So that's what I need. So again, we from here all the way we have a 2% fall. Now I could go on and on with these. These are, and I suggest that you go on and on with these. These are pretty cleverly put together. It goes back to double line, double line, double line. Remember, this is the end. So when you do your ditch, it says, and then I want you to cut 2 feet at 4 feet. And then, but you're measuring this cut and this distance from this last thing you did. How can I? So when you set this stake to get this, you started here and you went down 10 from here and you went over 20. Now, when you went to your hinge point, you came up 2 feet from here and you came over 4 feet from 20 to 24. You added it to get your 20, wherever that 24 went. I can't find it now. But we needed to be 24 feet to here. We needed to be 20 here. That gave us a horizontal of 4 feet, and that gave us a 2-foot difference between 10 and 8. This was 8. It won't show here, but this calculated out to be 8 foot. Cut 8 foot. This calculated to be cut 10 foot. So when I cut 8 foot, that gave me a 2-foot vertical, and I cut it 4 more feet away. Instead of 20, I cut it at 24. So I had that 4 feet as horizontal, and I had that 2 feet at vertical. So horizontal divided by vertical gives me my ratio. 4 feet divided by 2 gives me 2. That's a 2 to 1 slope. We had 5 feet here, I do believe, and we had, or do I believe? What did we have here? Where's that center line? 20 feet. There's a 5 feet. Let me get up here. I want to get way up here. Here, this was cut 7/9. That gave me a 1/10 higher. That's where I got that 1/10. And I was at 29. I was at 24, so I went 5 feet more. That gave me that 29. So it was 5 feet from here to here, and then it was 20. So I think I'm right. I'm not sure. 25, 25, 25. And that's from edge of pavement. I want to review that right quick. I may have to go up here to avoid confusion. This is a single line stake, 24, and that's where we got the 5 feet from here to here, 24. $29 is where we got the 5 feet. This was a cut 7. That was a cut This is the 7/9, so that's where we got that 10th for that little bitty 5-foot run here. And we have a 10, and that would be 2%. And this is 20, as I believe. So the edge of pavement is a cut of 7/9. The center line is a cut of 7/5. So that's where I got that 0.4, 0.4, 0.4 divided by 20 equals 0.02. Thank goodness, that's our 2%. I would like you, on your own, you could go back through these because this really does take you down. When you get to the point where you can, in your mind, start seeing to make this equal this over here, I'm going to have to, in a place here, if I want to be, I just cut, remember, just going over this real quick. If I cut 10 feet here and I cut 8 feet here, then here, if I fill 2/10, if I fill 2 feet, I will be 8 feet. But if I cut another, if I leave it alone, uh, if if I cut it, anything, it's going to get lower. I need it up higher so that we can come up that from that 8 feet to that 1/10 that I need here to get that 2% fall. So I don't blame you if you're scratching your head, and go through these. If we need to have a big bloop, see, it goes on and on. It's just doing the same thing. Repetition strengthens and confirms. So this thing goes on, and it's going to stop right here. I thought this was printable, but I'm not sure. But this is your circle. I promise you, if you get this down in your mind on percent grade, it's vertical divided by horizontal. Times 100 turns it into a percent. On slope ratio, it's horizontal divided by vertical. It's the invert of this. And you saw me time and again take that 4/10 vertical, take that 1/10 vertical, divide it by 5, and come up with a percent grade. So if you can copy this, just write it down on a piece of paper. Soon it will become a part of your makeup. I don't know if we have a next. Let's just see. I'm just kind of going on through it like, holy. This is your, oh, I didn't change this. These are, I gave individuals. This is time management. I will have this changed by the time you get to it. It says below is an article. Is the daggum article still there? Let me look. Yeah, the whole thing is here. So this is saying so-and-so, these are former students, so-and-so gets 6 and 4. So let me get this divvied up so that you will know which one of, what does it say first? I'm glad I went through this. Below is an article on time management tips for online students. You will each be assigned 2 tips. Let's see, I think there's 5 of you guys. So you will each be assigned, ever how that divides up. But I'll have it fixed by the time. Summarize each tip. Like for instance, if you have tip 5, what is that? Reward yourself. It's important to reward you. Just kind of summarize that. If you have 5 and 6, you would summarize reward yourself, create a balance. And gosh, you know what? I know what balance is. I swing by it all the time. So in addition to rewarding yourself, it's also, I'll have this divvied up, but you get it here. You know, if I knew how many of us there were, There's there'll be two of you guys from grades, and I think we have five, but no problem. By the time you get here, I'll have it. And by gollies, if I don't, you'll just have to wait. But I think I will. I want to get back to the module. Can I sneak back there? No, no, I gotta go there. I don't want to do that. We've already gone through that. Okay. This is your tailgate. Where'd it go? Week 7 tailgate time management. I'll have that fixed up for you. So we've gone through this right here. We know what to read. Uh, the assignment bears a little bit of looking at. So I'm going to take a minute and do that, and then I'm going to get ready for bed, my friends. Let's take a look at that before I leave you. Ah, this one I like. We've been doing cuts and cuts and cuts. Guess what? Fill. We're going to do a fill. Same principles. Look at this state. Here's the first part of it. And if you can't read it, be sure this is on page, but maybe I've got directions. Excuse me. Figure 1-4 below, located on page 12. This is on page 12 in your grading, excavation and grading handbook. So go there and you can read the states a little bit better perhaps. But here's what's going to happen. Look at this. Figure 1-4 below is located. Is located. I'm sorry, that's me. On page 12 of excavating. The difference in this figure and figure 1-1 on page 7, the one we was looking at earlier, is that figure 1-4 below is a fill state. The only difference is that you're bringing in material instead of cutting it. Now here's what's important for you. Given what you have learned and that elevation of the surveyor's hub is 96.60 feet. Where's the surveyor's hub? Right here. So that elevation right there is 96.6 feet above sea level. Look at your very first stake. Where are you going to put your reference stake? That's this dude. See the RS? Where's the elevation of it? Well, this says it's going to be, I can't read that. It's going to be fill 1 foot. No, it's going to be fill. Holy moly. I think that's an 8. It's going to be fill 1/8. Yes, it is. At 3 feet. So you're going up from here 1.8 feet and you're going over 3. So what is the elevation of the reference stake? Well, you know the elevation of the surveyor's information stake, and if you're going to go up as it asks you to do, once again I want to verify that, 1.8, then you're going to add 1.8 to this, so that's going to be whatever, 96.6. So here's a gift for you. 96.6 plus 1.8 equals 98.4. So what is the elevation of the reference stake? 98.4. It's that 1.8. And you guys get your book and make sure that I'm reading these numbers right yourself. You'll get it right. So everything's going to be like that. Look at, oh gosh, let's see. the hinge point. Where in the heck? There's the hinge point. To get to that hinge point, you're going to fill 5 feet. From the reference stake, you're going to fill 5 feet at 10. So you're going from whatever that was, another 5 feet. So fill in that blank. You know what this is, and from that you got that, and from that you'll get this, and so on and so on. We want the elevations. Is that what I meant? Yeah, calculate the elevations of the center line right here. Look at that 3%. I don't know how far it is from here to here. Let's take a minute and see if I can do this without. From the hinge point, it's 5. Oh, these are actually to scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20. That's 20 feet. Take the difference in the elevation here and here, and guess what? That's your vertical. And you would take your 20 feet, and I mean your difference, and divide it by 20, and I bet you'll come up with 3%. Give this thing a shot. You have a couple of attempts at it. This is all related back to those grades 1 where we talked about reference point to slope stake. Let me go back to the modules and see if I missed anything else that we might want to do. If you get hung up, give me a call, text, or I don't care whatever your means are. I'll be around. We've done that. The tailgate. I got to get your tailgate doable, and I'll have this published, and you can get started on this tomorrow morning. So have a good rest of whatever there is left of this weekend.